Okay, good morning. I think we can finally start now after this. So if you remember, we talked about finding the roots of a complex number. So let us have this z to be a complex number so that you can write it in the polar form, in the form of r times cosine theta. Let me just write it like this. I have a complex number, and then I have a natural number, and I want you to find the nth roots of z, because you will learn that there is not one single one of them. So let me write a formula. So I would write the nth root, or an nth root of z. I denote it by this symbol. And if you remember, I showed that this is equal to the nth root of absolute value of z. This is just the normal nth root of a real number, because absolute value of z, even though z might be itself a complex number, but its absolute value is a real number. So when I write the nth root, I am just meaning the normal nth root of real numbers, yes? And then, you remember, so you need to multiply it by the cosine of the argument of z plus 2k pi divided by n, and then plus I sine argument of z plus 2k pi divided by n. So, and then do you remember k goes from 0, 1, 2, up to n minus 1. The reason that we go up to n minus 1, because if we go further, we just repeat the same numbers, yes? So it is not mentioned in this way in the book, but I think now we can use this if we want to, yes? And there is a convention. Some of the books actually adopt that convention, some of them don't, and I think it's a very nice convention. In mathematics, in the real numbers, when I write a to power, for example, 1/3, and if I write the third root of a, they are completely equal in the real numbers, yes? But let us adopt this convention that when I write something in this form, let us differentiate it from what I write in this form in the complex numbers. Okay, that's just a convention, but I think it's a useful convention. When I write in complex number in this form, I mean the principal value. And do you remember what was the principal value? The principal value is the one which corresponds to choosing k equal to 0. Okay, so using this convention is very nice. So here you see that when I write this, that's just the normal convention. But when I write it in this form, I mean to express all of them. So if I ask you to calculate this, this is the convention that I want to use. If I ask you to calculate this, I mean calculate the principal nth root. Okay? But if I ask you to calculate this, I mean to give me all of them. So that's the convention that I want to use. Is that understandable? This is not universally adopted. Even the complex number books, they differ by these conventions. But I think the ones that are using this convention is very good for us. So let us differentiate between this one and that one. Whenever you see this symbol, I mean that you are interested in nth root of z, but which one? The principal one, which corresponds to choosing k equal to 0. And if I just write it in this way, it means that I am interested in finding for me all of them. Yes? And that is a little bit problematic, by the way, in the complex numbers. Yes? Why is that? Because why it's problematic? Because it loses the notion of a function. What is the meaning of a function? Now this is a little strange. If you go and see complex number books, they talk about multi-valued functions, which is a complete misnomer, because the meaning of a function, it means that it should assign a unique value to each value. Yes, that's the definition of it. For example, when you say that f of x in just real analysis, when you say f of x is equal to x squared is a function, you don't doubt. If I give you 1, what is the output? 1. If I give you 2, what is the output? 4. It is not possible to get you two different outputs for just one single input, yes? That is the meaning of function. So function by its definition means single valued. Okay, so that's a misnomer, but sometimes they use it in complex numbers like this. They say that this, in principle, this is not a function, because if I give you, for example, let me consider it a third. Do you remember, if I give you what is f of 1, this becomes 1 over 1 to the power of 1/3. But how many numbers are there in complex numbers? There are 3 of them. So this is a little bit confusing. This is not a function, so people call it multi-valued function, but multi-valued function is a misnomer from the beginning. Do you understand what I mean? So working with these kinds of functions in complex numbers, complex analysis becomes a little bit hard and confusing. But don't worry about this. So let us have this convention here. Let us have this convention that at least artificially differentiate between these two symbols, yes? Okay, so for example, if I write this for you, for example, if I ask you to calculate square root of I. Okay, so I want to calculate the square root of I. What I have to do, I need to know 2 things, okay? I need to know what is absolute value of the complex number involved, yes? So if according to this formula, what should I write? First of all, because you see this symbol, it means that I have to choose k equal to 0 by that convention. So what I write? I will write the second root of absolute value of I, and then I would write cosine. Okay, can you tell me what is the argument of z? What is the argument of I? Just imagine it, yes?
1.
No, argument.
Pi over 2.
Pi over 2. Argument is the angle that the vector corresponding to it makes with that. So it's pi over 2. But because of this symbol and this convention, what should I choose for k? I have to choose k equal to 0. And then what is n in this problem? What is n?
2.
2, yes, because I am interested in the second root, yes? N refers to the nth root. So here it's 2, and then I would write I sine pi over 2 plus 0 divided by 2. And then I calculate. So what is the meaning of absolute value of I is 1. What is the square root of 1?
1.
Exactly 1, because I am using the same convention. So I am using the principal value. So it becomes square root of, so it is just 1. So let me just don't write it down. So this is 1. And then what is happening here? So it becomes cosine. Pi over 2 divided by 2 is pi over 4. And then plus I sine pi over 4. And then cosine pi over 4 is a famous number. So it's 1 over square root of 2. And then plus I 1 over square root of 2. So this is interesting. So if you calculate the square root of I, this is a little bit odd calculation, so you might not be able to guess it out of the blue, you know. So this is the answer. Okay. So what does it mean? If I want to check my answer is sensible, what should I do? Square the right hand side to check if it is the left hand. Let us do that. Okay. So let us check this. To the power of 2. The first one to the 2 is 1 over 2. 2 times the first one times the second one. If I multiply these two together, it becomes 1 over 2. The 2 coming from the formula will cancel 1 over 2. It becomes I. And then this one to power 2. It becomes I squared, which is minus. And then this becomes 1 over 2. So you see, you can confirm it easily that the answer is I. So what we have done is correct. But if I write the same thing according to the convention that I am going to use, if I ask you to calculate this, there would be a little bit difference from this one. Yes? Here, if I write it in this way, I mean to find all of them. When I ask you to find all of them, the first part is as before. And then you write cosine, and then the argument is again pi over 2 plus, but you need to write 2k pi divided by 2 plus I sine pi over 2 plus 2k pi divided by 2. But this time I have to consider both of them. K equals to 0 and k equals to 1. For k equals to 0, I get what? I get 1 square root is the same thing, yes? Okay, can you guess what would be the second one? What would be the second one before the calculation?
The same, because you're adding 2 pi.
Okay, not
No.
you are using calculation. I'm not adding 2 pi. I'm adding 2 pi divided by 2 because there's a 2 there, yes?
The signs should be.
Yes, but I mean, without the way that actually calls it is based on calculation. Of course, it works. But what I'm asking you, do you remember if I ask you what is the square root of 4? How many square roots of 4s are there? There are 2. One of them is -2, the other one is 2. But by convention, we used to write this 2. Yes? But there is another one which is -2. So if everything should work as before, the next one should be minus this number. Yes? Because you want a number so that when you square it, it becomes I. When this number to power 2 is this I, it is clear if I multiply the whole expression by a negative sign and square it, it becomes again I. So if you don't believe that, you can calculate. So k goes 1, 1 square root is what? Let us check. If I put 1 here, let me calculate this 1 for 1. So it becomes pi over 2 plus 2 pi divided by 2. So it becomes pi over 4 plus pi. So where is pi over 4? In the unit circle, pi over 4 is here. But now I am adding pi to it. So I go exactly to this point, yes? Don't lock the door, please. Thank you. Okay. So the other one would be pi over 4 plus pi, so it would be here. Do you agree if the coordinates are x and y here, the coordinates are minus x and minus y here? So it means that so the cosine would be negative of this cosine, the sine would be negative of this sine. So it is clear it becomes minus 1 over square root of 2 minus I over square root of 2. So these are two square roots. Yes, is that clear? Okay. So from now on, remember it in your head. If you are talking about square roots, if you find the principal one, you really don't need to calculate the second one. The second one would be the minus of that one, yes? So yeah, you don't need to bother to calculate the second one if this is the square root. So for example, let me calculate this one as well. So if I write this in this form, 1 plus I to the power of 1/3. If I want to calculate this. So this is, there are 3 values for this because I have written it in this form. If I have written it in this form, then I mean just a square, just the principal value. So okay. So if I want to calculate this, I don't know, do you remember the formula now? So what should I write in front? I need to write the third root of
The
absolute value of this guy, and then cosine plus I sine. So what would be the denominator? 3, because I am working with third root here. So this would be 3, this would be 3. And then of course I will have 2k pi here, 2k pi here. But what is the number that appears here? The number, do you remember what was the formula? It was the argument of z. What is the argument of this number? Can you imagine it? It is easy.
45.
It's 45 degrees, yes? But let us write it in radians. So it becomes pi over 4. Pi over 4. And that's it. And then what the value of k is? The k is 0, 1, up to 1 unit less. So it is up to 2. So what is the absolute value of this guy? What is the absolute value of 1 plus I?
Square root of
The square root of 2, yes? And then I have a third root of a square root of 2. What would be that one?
this.
You should be quick in these things.
The sixth.
The sixth root, yes, because this means that the third root of 2 to power 1/2, this is just the real analysis, and then you write 2 to power 1/2 to power 1/3, and then you multiply, it becomes this, and then you can write this, yes? So that is the sixth root. So I would write it as the sixth root of 2. And then let us divide this by 3. It becomes cosine pi over 12 plus 2k pi over 3. And then the next one, the same thing. But of course, if you want to know more details, so you need to actually put k equal to 0. This gives you the principal value. So I don't know. We have 3 numbers. So if I put 0 here, this becomes the sixth root of 2 cosine of pi over 12 plus I sine of pi over 12. This is one of them. Okay, so I don't know what should I call it. So for example, let us call it W1, yes? This is one of the roots. And then the second root, this is the principal root, by the way, yes? So this becomes, for example, k equals to 1, so W2 is the sixth root again. But this one, if I put 1, it becomes 2 pi over 3, which is 8 pi over 12. I add it to this one, 9 pi over 12, it divides by 3, so it becomes 3 pi over 4. Yes? Am I right? I put here 1. I want to make the denominators the same, so I multiply by 4. It becomes 8, 9. Yes, that's correct. And then k equals to 2. Then W number 3. So this becomes this sixth root of 2 again, but the cosine, I put 2 here, so it becomes 4 pi. Multiplied by 4, 16, added to is 17, yes? So 17 pi over 4 plus I sine 17 pi over 4. So these are 3 roots of this differential, of this number. But the principal value, the principal one is this one. Is that understandable? Okay, so so let us check one of them. How do you check that these are correct answers? And how should we check them? Yes?
You can multiply them 3 times. Or...
No, it's simpler than that. Instead of multiplying 3 times, it means raise it to power 3, yes? Yes, raising it to power 3, we need the Demoir's formula. Let us double check at least one of them. Let us this time check the last one, if you don't mind. Let us see how you calculate. This is a good exercise in Demoir's formula. Okay, so let us check the last one if I have done everything right. So let me raise it to power 3 to see what happens. Okay, can you tell me, what should I write it? If I want to raise it to power 3, what would be the answer to the first bit?
Square root of 2.
The square root of 2, yes? So it becomes square root of 2. And then what happens for this part according to Demoir's formula? Multiply the argument by 3 instead of raising it. So it becomes cosine 51 pi over 4 and then plus I sine 51 pi over 4. Yes? So if I am right, this should be equal to this number 1 plus I. If I have done everything right. Let us double check. How do you check that, by the way? How do you check that this W3 that I have written in this fancy way is simply 1 plus I?
Find the end point for cosine.
Yeah, exactly. So what we do, we start from here. 51 pi over 4 is 48 pi plus 3 pi. Do you agree? Divided by 4. Yes? And then this one divided by this is 12 pi plus 3 pi over 4. This is a little bit straight. Now I think you're in trouble because this is not going to go back there. We get a negative sign out of it. Because 3 pi over 4. So did I do this one correctly? I put 2. Let me double check. If I put 2 here, it becomes 5 over 12, pi over 12. If I put 2, it becomes 4 pi over 3. So the common denominator is 12. So it becomes 16. Am I right?
Yeah. Yes.
Okay, it's divided by 12. I don't know why I wrote 4. So you see, it's good to check always. The reason it was 4, yeah, that one is correct because it was coincidence. It was 9 pi over 12. Yes? Yeah, it was 9 pi over 12, so I simplified, I accidentally wrote 4. So that's wrong, yes? So it's good to check that one exactly. So this is not correct. So what should I write? What should I write now? It becomes cosine of multiplied by 3. It becomes 17 pi over 4. Now, do you agree?
Yes.
Yes, that was my mistake. The denominator should be 12. Okay, so let us now, as you said, let us check this one. If I want to see what is 17 pi over 4, I write it as 16 pi plus pi over 4. Do you agree? Then I divide this by that, it becomes 4 pi plus pi over 4. But 4 pi is 2 complete revolutions around the origin, yes? And then I am left with this end point. Because the end point of this angle and the end point of this angle are both the same, so the cosines are the same, the sines are the same. So what can I say? I can say that the cosine of 17 pi over 4 is equal to cosine pi over 4, which is 1 over a square root of 2. And then if I ask you what is the sine of this angle is also the sine of pi over 4, which is also 1 over a square root of 2. Yes, then I plug this back there. So W3 to the power of 3 becomes equal to. This one is a square root of 2. Instead of cosine of 17 pi over 4, I can just put that number. And instead of that one, I put this number. Then I multiply square root 2 inside. The square root of 2 will cancel this one. 1 is left. The same story for the next one. And then I is left. And then you see that we calculate W3 to power 3. And it becomes equal to the 1 plus I. So what we have done is correct. But let me ask you to refresh your memory. If geometrically, where are these located? So if you want, I can go back. This was 9 pi over 12. Let us not simplify it in this case, even though that was right. So where are these points located? You need to know this geometrically, yes?
1/3 of a circle apart.
Pardon?
Shouldn't they be 1/3 of a circle apart?
No, 1/3 of a circle is, if I understood you correctly, it's 120 degrees. But no, just explain. I don't want, because this is pi over 12. Pi over 12 is 180 divided by 12 is 15. So this is 15 degrees. This is 9 times 15 degrees, and this is 17 times 15 degrees. But I don't care about. I just want to understand that these are lying on a circle. Yes? Which circle? Can you describe the circle? These points are lying on a circle. Which circle? Yes?
A circle with a radius of the 6th root.
Of 2. Yes, because all of them have the same absolute value. And centered at?
The origin.
Centered at the origin. So all of them lie on a circle with this radius, centered at the origin. But if I find these points on the unit circle and connect them, what shape should I expect?
Equilateral.
Equilateral triangle. So that's always, it's good to understand them. And as you said in the beginning, yes, they differ. How much? From here to here, I have increased by 8 pi over 12. And from here to here, I increased 8 pi over 12 again. But 8 pi over 12, it is 2 pi over. So you are right. Yes. So this is 120 degrees. So every time we are adding 120 degrees. Yes. I start from 1, which is actually with argument 15 degrees. Yes. So if I have the unit, not the unit circle, the circle of that radius. I don't know if this is 15 degrees. Each time I rotate it 120 degrees. And if I do it 3 times, it is clear I go back to the same point and I'm done. So those are the 3 points. So if I add the 135 degrees, yes, I don't know where that is exactly, but for example, if I really do this precisely, this becomes an equilateral triangle. So it is important to know this and to understand this geometrically as well. Okay, is that understandable? Okay, so let us solve some more interesting problems now. Okay, so let me ask your opinion about these problems. By the way, Do you remember we had this formula, AZ squared, ABC formula, BZ plus C equals to 0, yes? According to the convention is a very nice convention, I believe, because do you remember if I want to write the formula, it becomes minus B plus or minus square root of B squared minus 4AC divided by 2A. Yes, do you remember? That was ABC formula. But in this context, do you agree with me if I just write it like this? I am taking plus minus away, but I'm writing it in this form. Because if it becomes in the complex numbers, when I write something like this, I mean both of them. So in complex numbers, if I ask you what is this one, what is the answer to this? What is the answer to this? Plus or minus 5 in the complex setup. But if you put this in your calculator, because your calculator is using real analysis, you always get 5. Because there is a convention coming on. The calculator is only giving you the principal value. Remember that. This is the convention. If you want to have the convention in the whole complex numbers, calculator is always giving you the principal value. Yes? Okay. But in this context, if I write this, what do you answer? By the convention that I talked about, you just write 5. Okay? But I told you, this convention is not universally adopted. So might be in some books you see square root of 25 risen to plus or minus 5 again because they are using the same notation. But hopefully you agree with me, in the convention that we are using, we don't need to put plus and minus because writing it in this form automatically take care of that plus and minus. Yes? Okay, so now let us go and solve some problems. So what do you think about this problem? I want to solve these equations for me. So, yes?
Couldn't the formula be made even more simple by moving B to the back?
B to the back?
Yeah, so instead of minus B plus that thing, we have that thing minus B.
But then you need to write minus that thing again. So you are moving minus from B to that thing. Yes?
Okay.
Yeah, but you are right. Then because that one takes care of both plus and minus, that's also possible. Yes. Okay, so example, let me ask you to do this. Solve the following equations. Okay, so number 1. Z minus 2I times Z plus, I hope that I have designed it correctly. So yes, I want to solve this equation. No, it's quadratic equation. So what should we do here? Of course, this is not a big problem. Let us start. Everyone agrees that this is a quadratic equation, yes? So how should we solve that? So I would write that Z is equal to minus B, which is 2I in this case. So let us just use this convention, plus, and I would write B to power 2 minus 4 times A, which is 1, times 1 minus 2I. Two times A, which is this one. So don't get confused. I am using the convention that we talked about. So this is why I am not putting plus and minus. This way of writing automatically takes care of that plus and minus. So I have to simplify these things. I don't have any problems here. I don't have any problems here. Probably the main part is to calculate this one. And that is 1 to the power 1 over 2. Yes? So here, let us start from simplifying this expression a little bit. Yes. So what is this one? Minus 2I to power 2. Everyone.
Minus 4.
Plus 4.
Minus 4. Yes, because this becomes positive 4. I squared is minus 1, so it becomes minus 4. So let us just take that one. It's minus 4, and then minus 4 multiplied inside. It becomes minus 4 plus 8I. And I simplify that, it becomes minus 8 plus 8I. So this is the expression here. So do you remember, this is called the discriminant, even in Swedish it is the name, and we call it delta. So delta I calculated, it is this one. now I want to calculate 1 over 2, so we know the formula. So delta to power 1/2 is minus 8 plus 8i to the power of 1 over 2. But you know the formula. The formula is a little bit hard to master it, but it is simple when you work with it. So I need to write, let us memorize that right now. What should I write? I need to write the second root, because this is 2, of what? Do you remember? Absolute value of this number. And then I should write cosine, okay? And then I would write I, and then I need to put a 2 here, because I'm interested in the second root, and then I have a 2k pi here, another 2k pi here, and then, okay, now you need to tell me what is the argument. You remember that this one should be the argument. And I think this is also,
45.
it's not 45, because it's not in the first
minus
quadrant.
45.
It is how much? It is in which quadrant it is?
Second.
Second quadrant. So it would be pi minus pi over 4, yes? So which is 3 pi over 4. So this is 3 pi over 4. 3 pi over 4. And then you simplify that. K is equal to 0 and 1. And then I told you something about the square roots. For the square roots, you don't need to bother to calculate both of them. You just calculate the principal value for the other one. What you need to do? What you need to do for the other one?
Multiply
By a negative sign. So let us don't bother to calculate both of them. Let us just calculate k equals to 0. So if I calculate k equals to 0, then it becomes, by the way, can you calculate this in your head? What is this one? So the absolute value is square root of this one to power 264, this one to power 264. So it is 8 square root of 2, yes? Because 2 times 64, and 64 is 8 the square root of 2. So that is this one, but I need to take the square root. That was not a good idea, probably. Yeah, so let me just keep it like that. Square root of 128. But I need another square root on top of that, yes? Which becomes the fourth root of this number, yes? So let me write. The principal value, I don't know, let us write W0. It is good because this is 0. So this becomes the fourth root of 128. And then, because I have chosen k equal to 0, ignore this and ignore that, you get these two. Which are what? It's horrible to calculate, probably. So it becomes a cosine of 3 pi over 8 plus I sine 3 pi over 8. Yes? And can I simplify this a little bit? These are good things to learn, yes? 128 is 2 to power 7. 2 to power 7 can be written as 2 to power 4 times 2 to power 3. Yes? But when I am taking the fourth root of this expression, 2 goes out, it becomes, and this remains under the square root, under the fourth root, which becomes 8. So a better way of writing that is to write 2 fourth root of this. So then the other answer, you don't need to calculate. What would be the other answer? So let me, if you don't mind, let me clean this and write this number. It's easier to understand it. Yes? And then what is for K1? The K1 is actually W1, but W1 is nothing except minus W0. Yes? You can confirm that. You can put this number here. But then the real trouble actually starts here. Yes? Because I am not done, even though I was able to calculate if I was able to calculate these second roots. There are 2 second roots. One of them is W0, the other one is W1. Yes? But I have to plug them back here in this equation. Yeah, it is not hard, but let me just do one of them. So for example, z corresponding to 0, this is 2i. And then what I have to write this one is plus 2 fourth root of 8. So I can write plus and minus safely now, yes? Cosine of 3 pi over 8 plus I sine 3 pi over 8. And then divide the whole expression by 2. Yes?
Yes.
Okay, then what? do you agree that I can factor a 2 out? That 2 that I factor will cancel this 2. So then, so this is Z0 and Z1, both of them, not one of them. So this becomes I plus or minus the 4th root of 8 multiplied by cosine 3 pi over 8 plus I sine 3 pi over 8. This is the answer. There are 2 roots. But if I insist to continue, it means that you have to write it in a standard form. So what should I write? Can you help me? For example, for the Z0, which corresponds to the positive one, I multiply this inside, so it becomes the 4th root of 8 cosine of 3 pi over 8. And then, when I multiply this inside, there is an I here, there is an I here, I factor that I, so it becomes 1 plus the 4th root of 8 sine 3 pi over 8, and then times I. So this is one of the roots. So it seems complicated, so could you guess that this is the solution for this? Yes, it was not possible to guess. Is that understandable? So you see, I am just considering this positive sign. I multiply this inside. This becomes a real part. I multiply this one. It becomes imaginary part. So I put the real part here, but there is another imaginary part here, which is 1. I have to add the imaginary parts together. So that would be the answer. Okay, can you tell me what would be Z1? What would be the difference? I will have the negative sign. So this starts from the negative of that one. No, sorry. Negative of this one. 8 cosine 3 pi over 4 plus 1 minus the 4th root of 8 sine 3 pi over 8i. So these are the roots of this equation. Yes? But do you remember, I told you something in the previous session. This is 3 pi over 8. If you know enough trigonometry, which of course it is at the level of your knowledge, it is not beyond the Math 4 lesson, you should be able to calculate these numbers exactly. Cosine 3 pi over 8 is not something that you cannot solve. I will discuss about that one as well, because I want you to learn trigonometry as well. But let me just do this in a different way. Do you remember I gave you an alternative way, especially when you want to calculate the second root in the previous session? What was that?
Cartesian product.
Cartesian product. Yeah. Sorry, Cartesian coordinates. Yes. So only for, I would say that for the second root might be using Cartesian coordinates is a little bit easier sometimes, yes? So how should we do that? For example, my goal is to calculate the second root of this number. Okay? So let us understand what is going on. If I want to calculate this, let me clean this and write it from scratch. So my goal was to calculate this as z squared minus 2iz plus 1 minus 2I equals to 0, yes? If I want to solve that, how should I do this? Okay, so z is equal to 2I plus, so do you remember what was the number? Discriminant was this one, yes? And then divided by 2. That is my goal. If I want to calculate this, what should I do here? I would say that my goal is to calculate this. I want to know what that is. So what we do, I would say that let the question mark be, I don't know, W, which I can call it in Cartesian coordinates x plus yi. Okay? Then, what does this mean? It means that W squared should be equal to this number. Is that understandable or not? Yes? I want to calculate this question mark. I'm saying that this question mark is a complex number. So let me consider the Cartesian product, the coordinates instead of polar coordinates. And this means that if I square this number, it becomes minus 8 plus 8i. Yes? Is that understandable? Okay. Now I square it. It means that x plus iy to power 2 is minus 8 plus 8i. So if I square it using the formula, it becomes the first one to the 2 times the first one times the second one, plus the second one to the 2, which becomes negative y squared, is supposed to be minus 8 plus 8i. And then if I write it in an organized way, it becomes this is equal to minus 8 plus 8i. Yes? But this system is simple to solve. So it means the real part, this is the real part, agree, should match with the real part. And the imaginary part should match with the imaginary part. But let us divide everything by 2, so xy becomes 4. But solving this system shouldn't be in principle hard. Yes, because what can I do? For example, I take y to be 4 over x and plug it back here in this equation. So it becomes x to the power of 2. I raise it to power 2. 16 over x squared is equal to minus 8. And then I multiply everything by x squared. I move it to the right hand side. This is my equation. So I multiplied everything by x squared, and then minus x squared, I moved it to the left. It becomes positive. But this is one of those cases that you can solve. How? By taking x squared to be t. Then this equation becomes t squared plus 8t minus 16 equals to 0. So what can I do here? I can find my t. What is t? T is minus 8 plus or minus the square root of 8 to power 2 is 64 plus 64 again. Divided by 2. So the answer would be minus 8 plus or minus the square root of 128 divided by 2. But what can I write? I divide this by 2, it becomes minus 4 plus or minus. The square root of 128, square root of 128, do you agree? It is 8 square root of 2. Yes? And I divide it by 2, so it becomes 4 square root of 2. Yes? By the way, when I write w in this form, I am assuming that x and y are real numbers. So x is a real number. But which one is not acceptable here? This is the value for t, yes? But t is x squared, and x is real. So t cannot be negative. So it is clear minus 4 square root of 2 is negative. So throw it away. But 4 square root of 2 minus 4 is positive. So we have to keep only that one. So I don't want to clean this. So let me clean this one again. I don't know. So let me start writing here. So what happens? It becomes so t is only one number. 4 square root of 2 minus 4. This is the only acceptable t for me. But my goal is to find x. So what is x? X is plus or minus square root of this number. Yes, is that understandable? Because that is t. T is x squared. I want to find x. X is real, not necessarily positive. So I take the square root, it becomes that. And do you agree that I can factor a 4 out? And 4 will go out, becomes 2, and then I will have this. This is the x. Yes. And now I put it back to find my y. How? I put x here to find y. So y becomes 4 divided by that number. But do you agree? I can simplify this so it becomes plus and minus. 2 and 4 are simplified. And I get this. So this is y. Yes? Okay, now what is my w? My w is plus or minus. Instead of x, I put this. Instead of x, I put this. And instead of y, I put this. And do you mind if I can factor a 2 out? Yes, let me factor a 2 out, because there is a 2 here, there is a 2 here, I can factor it out. Both of them have plus minus, so let me put plus minus up there, and then I would write 1 over square root of 2 minus 1. This is my W.
Shouldn't it be I plus 1?
Yes, that is I, sorry. You're right. Because I need to write IY. Thank you. So is that understandable? So this is my W. Okay, the W that we get here is easier in form than this Z1, Z0, and no, that was the W that we got, yes? So this is actually correct. So if you compare these two things, you can immediately calculate these things. Because you have calculated the same things in two different ways, they have to match. So this number multiplied by that number should be 2 multiplied by that number. So actually, you used complex numbers to calculate something for trigonometry in real numbers, okay? I don't want to continue that. You put this back into this equation, and then you simplify and you get your answer. Okay, is that understandable? Okay. Let us do one more example here. This is actually a little bit horrible. Let me give you another example. I want to wait for you a little bit to see how you proceed. But I think for the quadratic equations, it is easier because you see what is the difference. If you just do it here, of course, this is also a little bit a strange number, but I hope that you agree with me. These numbers are better than trigonometric numbers, yes? They're more familiar for us. Okay, so let me just give you another example. So how you can do that, yeah, let me write it here for you. So z squared minus 5 plus 2i z, and then you have plus 2, I don't know, 21 plus I, yes, 21, yes, I remember now. 21 plus I equals to 0. We want to solve this equation. I can wait for you, by the way, so let me pause the video. Yes, it's working now. So let us just do it together. Okay, so first of all, let me calculate delta, not to mess the things up. So what is delta? This 1 to power 2. Because this 1 is gone because of 2. And then minus 4 times 1 times this number. And let us simplify that patiently. This 1 to power 2, 2 times the first one times the second one. This 1 to power 2. And multiply this. Yes, agree? And if I am doing something wrong, please let me know immediately. Yes? So what happens here, it becomes minus 88. What is that one? Minus 63, do you agree?
Yes.
And then this is 16i. So this is my delta. But I am interested in calculating, let me calculate the square root of delta instead of calculating both of them. And then we know that the other one is negative of this one. But if I want to calculate delta, a square root of delta, it means that I want to calculate the square root of this number. So what should I do? I would say that let this be equal to x plus yi, question mark here, question mark here. I want to calculate this and write it in a standard form. I don't know these numbers, but I know that if this is going to work, a square of this one should be equal to that one. So this means that x plus yi squared is equal to this number here that you see, 16i. So this 1 to power 2, let me just skip this one because that is exactly the same combination. And then we have minus 63 plus 16i. Yes? And then I get a system of equations. So this is always the same. You don't need to bother yourself that much. So this becomes this number. And then what is xy? Do you agree? It becomes 8 because I am dividing it by 2. Now I need to solve this system exactly as before. So the good point about this method is that you just follow the recipe.
Mr. Babak, why is it minus y not plus y?
Where is
I squared is minus.
this one? The first one is squared, the second one is squared. Yes? So you haven't get used to this yet. I squared is minus 1. So you put it back into this equation. So this becomes x squared minus 64 over x squared is equal to minus 63. And let me multiply it by x2. X to the 4. I bring it to the left. It becomes positive 63x squared minus 64 is equal to 0. How do you solve this one now? This was a nice problem. I took it from an Indian book. Now I realize they have designed it to be simple. So, do you see? I can factorize it. I need two numbers whose sum is 63 and the product is minus 64. It's easy to guess. So let us just, what should I write in the pair of brackets? Can you tell me? What should I write here and here?
Should be x2.
x2, yes. x2 here, x2 there. And I ask myself, I need two numbers whose sum is 63 and the product is minus 64.
64 minus 64.
Yes, positive 64, negative 1. It was super simple, yes? So they have designed it in a nice way because it was in an exam. Yes? But be careful. If you want to solve it using the other method, it's completely horrible. Yes, why? Because the argument of this is not known to you, not even for me. Argument of this number is 16 over this. You need a number whose tangent is this somehow, and then subtract it from pi. So if you write it like that, it becomes horrible. You see, alternative methods, even though they are completely equivalent, so it's completely from practical point of view, one method might have a very huge advantage of the other one, yes? So be careful. If you want to solve this problem, more or less I would call it a dead end if you want to write it in polar form. If you want to do it by hand especially, yes? Is that understandable? Everyone? Yes? Okay. But now you see it's super simple. The product is 0. Let me test your understanding. Can I solve it like this? Yes or no? I guarantee that this calculation is true. You need to. You have my words. 100%. This calculation is correct. But should I do this?
Yeah, it can't be minus. Yeah, no, never mind. I said nothing.
Okay.
X should be a real number.
A real number. Yes, I told you several times. When you use this method, Cartesian method, you are assuming that x and y are real. So when I am assuming x and y are real, there is no solution in the set of real numbers for this. So even though this calculation, without knowing that you are working in this context, is correct, but in this context you don't need to consider that at all, because x and y are assumed to be real. So then it means that this only gives me x squared minus 1 is equal to 0. And what is x? X is plus or minus 1. Super simple, yes? If I put it back here, y becomes equal to 8 divided by plus or minus 1, which becomes plus or minus 8. So it means the question mark is x equals to 1, y equals to 8, so it becomes this, or minus 1 minus 8. Yes? So I was looking for x and y. So you see, it's completely horrible if you don't believe. By the way, if you have access to Alpha Wolfram or something, of course you can have, I think the free version is capable of doing that. I would recommend you to solve this using the polar coordinates. If you want to learn mathematics, by the way, it's extremely important to solve one problem from different perspectives. It teaches you a lot. Yes, it's really, really important to that. And then, of course, if the numbers are horrible, let us see that you can get the exact numbers like that using the computer. If you can do that, it means that your understanding in that perspective is also perfect. Okay, so now we have everything, but I want to calculate z. So what is z? Z has a formula, minus b, which is 5 plus 2i, plus or minus, of course plus or minus is clear, so let me write plus or minus 1 plus 8i, and then divided by 2 times a, which is 2, yes? And this is very simple now, yes? So I have two roots for this equation, z1 and z2. I choose the positive sign first. 5 plus 1, 6 divided by 2, 3. 2 plus 8, 10 divided by 2, 5. This is one root. And the other one, I took the negative sign. 5 minus 1, 4 divided by 2, 2. And then 2i minus 8i is minus 6i, and divided by 2 minus 3i. So finally, these are the numbers. So you see, they have artifacted in a very nice way. They are testing your understanding, and you are not messing up with those very bad numbers. Okay, so this is something good to know. Yeah, we have 15 minutes. So let me start with the next. I will not start the next lesson, but let me give you another problem. See what is your opinion about that here. So let me clean this. So next week is a complete week or not? Yes, we have. Yes. For you, it's not a complete week, is it?
Why wouldn't it?
Yeah, if it's so I am sure that we have the Tuesday. Do we also have the Friday?
Yes.
Okay, so we will finalize this chapter next week. So let us because the next lesson is also very, very important. Okay, so let me ask you this question. Example. If z squared minus 2z cosine theta plus 1 is equal to 0 for some theta in real numbers in R, show that z to power n plus z to power minus n. No, not show that. Let me ask you, determine. Because I don't know the answer. So determine this combination for the natural number n. A natural number n. Of course, I mean in its simplest possible form, in its simplest possible form. Okay, so let us see how you think about this problem. It takes probably 10 minutes to solve it, so let me give you 5 minutes to think about it, okay? So don't get confused, this cosine theta. Theta is just an arbitrary number. We know that z for that particular theta satisfies this equation, and then I give you a particular natural number n, and I ask you to calculate this in its simplest possible form. So z is a number which satisfies this equation for that given particular theta, and I give you n, and I ask you to calculate this combination. Yes, just give you 5 minutes, and then I will start solving it after 5 minutes. Put it back. Okay, the first part, I don't think you have any problems, okay? So you want to solve this. So can you tell me what is playing the role of a in the quadratic equation there? Yes, it is 1. What is b in that problem?
2 cosine theta.
Minus 2 cosine theta. Of course, it doesn't matter here because it would be squared at the end. But let us keep it right. So c is 1. So let me just calculate delta first. So delta is b squared minus 4ac. This 1 to power 2 is 4 cosine squared theta minus 4 times that is just 4. Okay, how do you continue from here? Did you finish? Yeah. Just bring it here, please. Did you hand it?
Yeah.
Yes. Is that okay now?
Yeah, that's fine.
Good.
Where do you want this? Oh.
Yeah, just put it somewhere. Find it. Yeah, that's here. Yeah. Yes, there is a box. Blue box. Yes, thank you. Okay, and then what should I do from now on? If you want to do this, just give me suggestions. How do you proceed? Yes?
Write out the rest of the z. so that you get.
Not yet. I myself, I will not start writing out. You might have different strategies, but I will continue a little bit. Yes?
Factor out 4.
4. That's at least the way that I think. But even I don't stop here.
There's a formula for
Not exactly, but it is close to one of the famous formulas. Yes?
sine.
Yes?
Theta.
Yes, so we know that sine squared theta plus cosine squared theta is equal to 1. So I move 1 here, I move sine there. So it becomes cosine squared theta. I keep it here, I move 1 to the left, I move this to the right. Yes? So cosine squared theta minus 1 can be written simpler in this form. So let me write it here. So it's minus 4 sine squared theta. Okay? But now let us, as you said, continue to find z. So what is z? It's minus b, which is 2 cosine theta, plus or minus square root of minus 4 sine squared theta. Okay, so let me be a little bit patient. So let me calculate the square root of delta first for you, the principal value. So can you calculate this one for me? Oops. Yes?
Isn't it 2I sine theta?
Yes, do you agree? Because this I can write it as 4 sine squared theta multiplied by square root of minus 1. That's the mean. But square root of minus 1 is I, and this one is 2 sine theta. Yes, so this becomes I. And then usually, let me put a pair of brackets around. So it is easy. But now I go back to calculate z. So what is z then? Z is minus b. Now I am safe, I can put plus and minus 2I sine theta, and then divided by 2 times a, which is 2, and that's a famous combination now. I factor a 2 out, and then I cancel that 2 that is coming out with this 2, so I get the answers. Z is equal to cosine theta plus or minus I sine theta. As simple as that. So these Indians are actually very good in designing questions, yes? They are nice at the end. Okay, so the reason is that they have only 90 seconds to solve the problem. So if you want to have very hard things, you cannot do it, and the calculator is not allowed. No formula sheet is allowed. So just go with your pen and paper in the exam session. Okay. And the questions are very crazy because they have multiple choice questions with more than one answer is correct. So for example, if you solve this equation and find, oh, my solution is one of the options, might be 2 of them should be correct. So you need to calculate all 4 of them, and at the end, if you have 2 questions correct, you need to check 2. If the 3 of them are correct, you should check 3. So it's a very crazy idea of taking the test, but I really enjoy the questions. Okay, so now what is your suggestion? I want to calculate this combination, yes?
No, what type of test did you say it was?
The test is going from high school to university for technical programs. Yeah. Yeah. So it is stressful. Probably many people commit suicide. Yes. Yeah, it's really, really competitive, but probably they don't care. They just care to pick the best ones. And I think the CEO of Google is an Indian one, so it's clear why, probably. Okay.
They have a similar test in South Korea, where people.
No, this is even China. I saw it's a famous test. I forgot the name. The name that this name for Indian ones is JEEIIT or something, advanced. But for China, there is also a famous test, but it's not comparable with the questions here. I don't know how they, but of course, this is why they use their memory a lot. Okay, so yeah, this is a word on itself. So that is an industry. The bad point about these very hard questions is, unfortunately, the test itself becomes the goal.
And usually because you have under so many pressure, of course in universities they are also very tough. So yeah, the Indians are very good in both cases. But in principle, in Iran, the entrance exam is very hard. But when you go to the exam, to the university, the exams are not so hard. People are failing, things like that. You lose the interest, you know. Yes. Okay, so yes, let us continue. But the rest of it is actually simple. So what is this? Z to power n, I want to calculate it. I have two options for Z, but let us take one of them, for example. Let us consider with the positive one. And I ask you to calculate Zn. Zn is easy to do. What is Zn? Just tell it to me.
Cosine n.
You just multiply by n, yes? So it becomes cosine n theta plus I sine n theta, yes? And what is Z to power minus n?
Minus cosine n theta.
No. I need to multiply by minus n. Do you remember I told you that for negative integers that is formula is also correct. So Demoir's formula is not only correct for positive natural numbers, but it is also correct for negative natural numbers. So it becomes cosine minus n times theta, but cosine of minus theta is equal to the cosine of theta. Is that understandable? Cosine of minus alpha is equal to cosine alpha itself, but sine of minus alpha is minus sine alpha. So if I multiply n here by negative sign, it becomes negative n theta, but that negative because of sine goes back outside. And then you see how nice the problem is, because I want to add these two. And then when I add them, this is cancelled. And then z to power n plus z to power minus n becomes 2 cosine n theta. That's it. And this is the simplest possible form of this expression. Okay, and then what happens if I choose the negative sign? Do you think that the result would be different?
No.
Let us check. If I choose the negative one, okay, I raise it to power n. Do you agree this n goes here and this n goes there? And then if I raise it to power minus n, this becomes cosine n theta again, but this minus n will go out. This time this becomes negative, yes? And if I add them again, the result is the same. So it is independent of which value you choose. You can have this. If this is true, this expression is always 2 times cosine n theta. Yes? Yeah. Any questions here? Okay, thank you. We stop here.